natural logarithms, or we can say logarithms in base e. Okay, so you may remember the base of natural exponential functions in the form y equals e to the power of x, and these natural exponentials had the base e equal approximately to the value 2.717228 and so on. So this was the natural exponential function, and here it is depicted in green as this curve in a picture, and you can see that this natural exponential e to the power of x passes through the point 0, 1 and also through the point 1 with coordinates 1 and e. So instead of this ugly form I can have 1 and e as coordinates of this point. Now the inverse function to the natural exponential function is what we call the natural logarithmic function, or the natural logarithm of x. So f inverse is y equals the logarithm in base e of x, or we just use this simple symbol logarithm, natural logarithm of x, ln x. So it's depicted in blue in this picture. It passes through points 1, 0 with coordinates 1 and 0, and through this point with coordinates e and 1, like that. So it's very similar to what we talked about in previous lessons when we talked about logarithms. This time the base is e, and the only thing that differs is the way how we denote these logarithms. Natural logarithms are denoted just by the symbol ln of x, natural logarithm. So it comes from Latin logarithmus naturalis, like that. So this is the meaning of these two letters, ln, or you can imagine it to be logarithm natural or something like that. Okay, now what would the definition of the natural logarithm be? So the natural logarithm of a positive number x is the power y that e must be raised to in order to obtain the number x. So two equations hold true. X is e to the power of y, and if this is so, if it is y that we have to raise e to in order to obtain x, then we say that y is the natural logarithm of x. Now, the consequences are very simple. These two equations are equivalent to each other. So if I say that x equals e to the power of y, it's the same as if I said that y was equal to natural logarithm of x. Another consequence is that if you take this function y equals logarithm of x and you replace x with e to the power of y, so you end up with the logarithm of e to the power of y, which is this first formula which says that for all values y, for all real values of y, the logarithm of e to the power of y is just y, and that's it. And the other formula is obtained if you start with this, you say that x equals e to the power of y, but you replace y by what it is, so you can say that it's e to the power of natural logarithm of x. So x always equals e to the natural logarithm of x. So this second formula holds only for positive values of x, because only positive values can be the values of any exponential function. Now we can also note some particular consequences. For example, what the natural logarithm of 1 should be. Okay, so the natural logarithm of 1, since 1 can be expressed as e to the power of 0, is the natural logarithm of e to the power of 0, and e to the power of 0, according to, well, which one? This formula here, logarithm of e to the power of 0 should be just 0. So therefore, logarithm of 1 is 0. And it is also, it can be seen here in this picture that the natural logarithm of 1 is 0, because this curve passes through the point with coordinates 1 and 0. Moreover, natural logarithm of e itself which can be written as the natural logarithm of e to the power of 1, must be 1, and it's also the consequence of this formula that the natural logarithm of e to the power of y is just y. Okay, and the reason for that is also documented here by this curve. If we take the natural logarithm of e, which is somewhere here on the x-axis, then we get the value of 1, because it has to pass through the point with coordinates e and 1. Now, this formula here, well, it says that whenever you want to replace an integer with a logarithm, you can do it as this. Well, this actually is just the consequence of this formula, which was true for all real numbers, but this time we are using it only for natural numbers. So it's just natural to say that n is the natural logarithm of e to the power of n. Finally, we have, well, the last two ones. So the logarithm of the square root of e. The square root of e, as you well know, is e to the power of 1/2, and it means that since this is so, and we can use this formula that the logarithm of e to the some power is just this power, we can say that it's just 1/2, like that. And finally, the last one is the logarithm of 1 over e. Well, 1 over e is e to the power of -1, and this should be just -1, because for y we can take number 1, -1 as y in this equation, which holds true.